Good morning everybody. Today we are going to discuss about a very fundamental things of thermodynamics, that is thermodynamic system, surrounding and the universe. So today's discussion will be based upon how to define a system, what are the classification of the systems, what is a system boundary, what is surrounding, and what exactly you mean by the universe. Now to define, as you can see in the slide, a system is defined as a certain quantity of matter or a region in space on which our attention is concentrated in the analysis of a problem. And when this system or the study of the system is related to thermodynamics, it is called a thermodynamic system. Now if you see this definition, there are two things which is given emphasis to. One is a certain quantity of matter and the other one is a region in space. And why these two terms have been used to define a system, I'll explain. So, what is a system? A system can be defined as a certain quantity of matter. Next, it is a region in space on which our studies are concentrated. Now, for example, let me consider a cup of tea, suppose 100 ml of tea, which is kept inside a room, and I want to study the temperature behavior of this tea with respect to time when it is kept inside the normal temperature of body temperature. So now this 100 ml of tea, which is a certain quantity, becomes my system, because my studies, my observation is concentrated on this 100 ml of tea, which is a certain quantity. Another case may be, I'll take a cube of ice. Suppose let us say 1 kg of an ice cube, which is kept open to the atmosphere, and I want to study at what time or how much time is required for the ice to completely melt and come in thermal equilibrium with the surrounding. So in this case, this 1 kg of ice, which is a certain quantity, becomes the system for me. So these are the two examples of certain quantity of matter being defined as a system. And when the system is defined in terms of certain quantity of matter, it is called a closed mass system. Control mass system. Now, coming to the next part of the definition, the system may sometimes be defined as a certain region in space on which our action is concentrated. For example, let me consider a compression in which the air enters at 1 bar and leaves at 10 bar. And in this case, let me define this specific space or specific volume as a system. Now if I see, the air enters the system and also leaves the system. So there are not certain quantity of air on which my analysis is made, rather it is a certain region in space or a certain volume on which my action is concentrated, and here this region in space is called my system. Region in space. Here there is not certain quantity. Similarly, I can take the example of a boiler in which water is heated from outside and this is converted to steam. In this example also, if I take the surface of outer surface of the boiler as my system, okay, then this is also not a certain quantity, rather a certain region in space which I am studying about, and here that is the definition of a system. And this kind of system, which is defined by the certain region in space, is called a control volume system. So this is how we explain a control mass system, which is a certain quantity of matter, okay, and then a control volume of system, which is a certain region in space. Now the details about the classification of the system we will discuss a little later. Now coming to the next part of our discussion today is what do we mean by the surrounding. Okay, as you can see here, anything external to the system that interacts with the system is called the surrounding. So anything that is not included in the system is called the surrounding. And what is a system boundary? A system boundary is a real or an imaginary surface that separates the system from its surrounding. So system and surrounding are separated by a boundary called system boundary. So as you know, there is a system, then there is a system boundary, and then there are surroundings. Okay, so system, then the system is enclosed by system boundary. Anything external to the system is called surrounding, and the system and surrounding together, the system and surrounding together is called the universe. You can see in this slide that how a system and the surrounding and what is the universe. A system boundary, a surrounding, and the universe. So the system and the surrounding together is called the universe. Next part we will discuss about what are the different kinds of boundaries. Okay, the boundary, as I told, the boundary can be real or imaginary. Also, the boundary can be fixed or movable. Now coming to boundary, it can be a real boundary or it can be imaginary boundary. For example, the same example I will take, that is the cup of tea. Okay, condense amount of tea, and this becomes our system. Okay, now if you see this portion, and this portion, they do not move relative to each other. Do not move relative to each other. They are called fixed boundary. Okay. Also, these three boundaries, they are physically present, so they are real boundary. But this space, this portion, there is no physical boundary present, so this becomes an imaginary boundary. So this portion is an imaginary boundary. These three portions are real boundaries as well as fixed boundaries because they do not move relative to each other. But there are some instances when the boundary moves relative to each other. For example, a piston cylinder arrangement. A piston cylinder arrangement in which I take this as a system. So, if you see this portion, and this portion, this blue dotted portions, they are not moving relative to each other. So, they are fixed boundary. Whereas this particular portion, this tends to move to and fro according to the movement of the piston. So this portion of the boundary moves with relative to the other portions of the boundary, and that is why it is called movable. Movable boundary. So the boundary can be real or imaginary, and simultaneously the boundary can be fixed or movable, as shown in the example. Then we will discuss about the various classification of the system. If you can see here, the thermodynamic system can be classified depending upon the interaction of the system with the surrounding. And how the interactions are classified as? There may be three cases of interaction. One is a heat interaction, a work interaction, and a mass interaction. So, the interactions may be of three types. If I take again a system consisting of a piston and a cylinder, this is my system. Number one is heat interaction. Number two is work interaction. And number three is mass interaction. Okay, so that means heat can supplied to the system or rejected from the system. The work can done by the system, or work can done on the system, or in some cases there may be mass flow into or out of the system. And depending upon these three interactions of the system with the surrounding, the classification of the system is done. So how the classification is done? If you see in the slide, what is an open system? An open system is one in which both mass and energy interaction is allowed. That is, both mass and energy can cross the system boundary. We have already discussed about what is a controlled volume system, that's a region in space system. So that system is nothing but the open system. So an open system is one in which both mass and energy interaction is possible, or both mass and energy can cross the system boundary. Similarly, what is a closed system? A closed system is one in which energy interaction is allowed, but mass interaction is not allowed. It is restricted. That is, mass can cross the system boundary, but energy cannot cross the system boundary. This closed system is also called a controlled mass system. And the third type of system is an isolated system in which neither mass nor energy can cross the system boundary. That is, none of the three interaction, that is heat interaction, work interaction or mass interaction is allowed. So, first is closed system, also called controlled mass system, in which energy can cross system boundary. Mass cannot. For example, you take any closed vessel. Any closed vessel. Next is open system. As I told you, this is also called control volume system. This is also called control volume system. Here, both mass and energy, interaction possible. For example, all steady flow devices, that is compressor, boiler, turbine, etc. Okay, and the third case is that of an isolated system. And as explained already, all the interactions are possible, that is not possible, that is neither mass nor energy. Neither mass nor energy can cross system boundary. What is an example? The example of any closed insulated vessel like a thermoflask. Thermoflask is not perfectly insulated because there are some amount of heat losses always present, but considering as ideal case in which the thermoflask is perfectly insulated and there is no heat loss, we can assume that to be an isolated system. Our universe is considered as an isolated system. So this is how the systems are classified as open system, that is controlled mass system, closed system, that is controlled volume system, open system, that is controlled volume system, closed system, that is controlled mass system, and finally isolated system. If you can see this figure, there are three examples. One thermoflask, that is the example of a isolated system, an open vessel in which the mass flow is possible, that is the first case is the case of an open system, and the middle one is the closed vessel. It is an example of a closed system because the energy can cross the system boundary but mass cannot. So this is how we got a broad idea about what is a system, what is a system boundary, what is a surrounding. What do you mean by universe? That is taking into account both system and the surrounding. What are the different types of boundaries, whether it is a real boundary, an imaginary boundary, or whether it is a fixed boundary or movable boundary. And finally, what are the classifications of the system? That is a closed system, that is an open system, and finally an isolated system. This is what all about thermodynamic system and surrounding is. Thank you.